So in this unit, we're going to talk about something called rational numbers. And before we talk about what exactly they are, let's talk about some other types of number systems that you already know. Okay? So the first set, and actually you don't have to worry about these number lines, I'm not going to use them. We have what's called the natural or counting numbers. Those are the numbers that start at 1 and keep going up by 1 forever. So we call them capital N, and the way we show it mathematically is we use a brace, and then we just write the first few, and then dot, dot, dot to show that that continues. Okay? Those were the first numbers used. But then there was a need. How would you show the number that represents nothing? Well, a new system was created, and it wasn't very different from this, because all we did was add 0 and then kept going up forever. And those are the whole numbers. So every natural number or counting number is also a whole number. But not every whole number is a counting number because 0 is whole but not natural. Then there was the need, as businesses started to grow, for negative numbers. What happens if you owed something? So therefore, we had to add negative numbers to all the numbers. And those were called the integers, which we reviewed in the last year. Now, we actually use the letter Z to talk about the integers, because I represents something else in math. And how do we show those? Well, we start at 0, and then we go up by 1s forever. But then we also start at 0 and go down by 1s forever. So that's how we show integers mathematically. Basically, positive and negative whole numbers is what you can say. But then there was the need for how would we show part of a number? In other words, fractions or decimals. And therefore, a new system was created called the rational numbers. Rational numbers, we can't write a notation for them because I have no idea what the first rational number is after 0. Is it 1/1,000,000th? Is it 1/1,000,000,000th? I have no idea. So we can't write it using notation. All we can write is we can define it to say as any number that can be written as a fraction. With one exception. As long as the denominator does not equal 0, because we can't divide by 0. So that's a whole bunch of numbers. So what kinds? All positive and negative integers. So all the numbers on the previous page. Fractions, positive and negative fractions, decimals, because decimals is just another way to write a fraction. And for decimals, only the decimals that terminate, meaning they end like 0.5 and it stops, or repeating. Like 1.3 repeating. All of those are rational numbers because we can write all of those as fractions. So, examples. Well, any fraction. So, -5/7. Why is that a rational number? Because you can write it as a fraction. (0.2). Why? Because you can write it as a fraction, 2/10 or 1/5. (5.5) repeating. Because you can write these as fractions, 5 and 5/9. What about all the numbers on the previous page? Is 3 a rational number? Can you write 3 as a fraction? Yeah, just toss it over 1, right? So any number on the previous page, the whole numbers, the natural numbers, the integers, they're all rational too, because you can write them all as fractions. So 0 or -10. There's probably only one number you're aware of that you can't write as a fraction. Yes, because pi never repeats or never ends, which means it's impossible to write it as a fraction. So I'm going to put it in here and then just cross it out, because it's not. There's actually a whole bunch of other non-rational numbers that we'll talk about in later years. One thing I want you to note, because we're going to focus on rational numbers that are fractions. We'll do a little bit of decimal, but any kind of work we do with decimals, you'll be using a calculator, because you guys did the whole operations with decimal things in middle school, okay? So it's assumed that you guys know how to do that. So therefore, we use a calculator. Whenever we write a negative fraction, there's three ways you can write it. You can put the negative with the numerator, or you can put the negative with the denominator, or you could put the negative right in line with the fraction bar. All of those mean the same thing. So you can move the negative. You can have it up top, on the bottom, or in the middle. However, would this be the same thing? Why not? Shay?
2?
Yeah. Would make a? Right. This would make a positive. This would be positive 2/3. So we would say doesn't equal. We put a slash through the equal. That means not equal. Okay. There's a way to show all these number systems visually using this diagram. we start with, in the smallest oval, those are all the natural numbers. And remember, every natural number is also a whole number. So therefore, the natural number oval is inside the whole number oval. Every whole number is also an integer. So all of these numbers are inside the integer oval. And all of them can be written as fractions. So they're all in the rational number. And this is how we denote rational numbers, with the capital letter Q. Okay. And if it's, you can't write it as a fraction, you put it outside the biggest oval. So here's a question for you. In which oval would I write the number -2? Here? Yep, check. In the integer one, right? It's not a natural number, so I can't put it in here. It's not a whole number, so I can't put it in here. It's a negative number, which means that's the furthest inside it can go. Who wants to come up and put right where the fraction 1/2 would be? Who thinks they know where 1/2 would be? Everybody not making eye contact, looking down at their paper, looking up at the sky, praying that he doesn't call on me. Where would we put that? Yep. Well done. 7. Okay. Yes. -2.6. 2.6.
Wait, after me.
We're going to put -2.6. Well, let's eliminate here. No, not here, not here. Right? Because these are only whole numbers, positive, negative whole numbers. So it's got to go outside Z. But can you write it as a fraction? Can you write any decimal as a fraction? Yeah. So it would go in this oval. What did I say? -2.6.
Yeah.
0. Where would I put 0? Yes. Pi. Where would I put pi?
Is it outside here?
Yep. Let's try some. There you go. Good job. 0.3 repeating. 0.3 repeating. Well, eliminate the ones you know it can't be in.
Not the first one.
Yeah, not n.
Not this.
All right, yeah. And then I got one more for you. Yeah.
7.
We want to put it in the one that most inside. Yeah. It is a whole number, but it's even more specifically a natural. Finally, square root of 25. Square root of 25. Think of what that is. Think of what that is. All right, Romy. Square root of 25, where would it go? Exactly. Because it's 5. Actually, I'm going to write it square root. Because you can write it as 5, and 5 can be written as the fraction 5 over 1. Well, it's a rational number, but most specifically, it's a natural. Good. Okay. Some examples. And before I do that, what do we call all of those numbers together? They're all part of one big system called the real numbers. Excellent. And we use an R. That's why we don't use R for rational numbers, because it's for real numbers. Okay, so how would you write these things using rational numbers? So in other words, positive or negative, and then whatever number. So the temperature is 8.2 degrees Celsius above freezing. How would you write that? Like positive, negative, and what number? Positive 8.2. We don't put the units, we're just asked to write it as a natural number. Or sorry, as a rational number. Stephanie owes her parents $24.50. Exactly. Negative 24.5. And when we just list the number, we don't put any units. Julia has earnings of $100. Yes, she's over there. Positive 100. No dollars. And the diver was 3.5 meters below sea level. Negative 3.5. So remember, what kind of words mean negative? If you owe something, if it's below freezing or below sea level, things like that. This next page, this is just some common fractions and their decimals. You guys should have done this previously, okay? I mean, I'm not going to get you to memorize them or anything like that, because you can use a calculator, but you should be familiar with some of them, like a half is 0.5 or a quarter or 3/4. But of course, you can always change a fraction to a decimal by dividing. So if you're not sure what 9/10 is, just go 9 divided 10. Okay, 2 other things I want to look at. How do we order these things? And how do we put them on a number line? Well, this one we got 5 numbers, and we're asked least to greatest, or smallest to largest. What might be a good idea, keeping in mind you have a calculator, and how to compare these, or how to order them? What might you want to do with some of them? Ava? Yeah, change them all to decimals. So 4 over 5 is 0.8. 7 over 8 is 0. Oh, come on.
Wait, I'm getting my calculator.
You're killing me. Slowly.
Wait, I'm 0.875.
0.875. You should be able to tell me now this one without a calculator. Negative 0.875. Okay, so we've got them all in decimal. Now we're ready to order them. So remember, the opposite happens in the negative world, right? Like 2 is greater than 1, but -2 is smaller than -1. So the reverse happens. So if we're going the lowest to highest, or least to greatest, we want to focus on the negative numbers first, right? These obviously are going to be high because they're positive. So I've got to look at this one, sorry, this one, and this one. Which of those is the smallest? Ava.
Negative 1.2.
Negative 1.2. Okay, that one's right. Now I gotta look at these ones. Which one's smaller, negative 8.75 or negative 0.5555 per annum? Remember, the bigger the number it is, the smaller it is in the negatives. Romy? Right. Negative 0.875, or the original one, negative 7. That takes care of that. Well, there's only one more negative. They're up here, see, the lessons that, oh, you do, okay. So obviously that has to be the next one. Now we're down to 2 positives that we changed to decimals. Which one's smaller? 0.8 or 4/5. That leaves 0.875 or 7/8. So that's the first step. Now, next step, we got to put these numbers on the number line. So let's start with 0 here, and then 1, 2, and then -1. Where would I put negative 1.2? Give it a shot. Negative 1.2. Yep. Put the negative in front. Good. Yep. Right about there. Doesn't have to be perfect. Okay, I mean, like, if you put it over here, that's not negative 1.2, but that's good. That's fine. Where would I put negative 0.875? See? Yep. Good. Thank you. Yeah, right about there. How about negative 0.5 repeating, which is really, really close to negative 0.5, which is negative 0.5. Here, halfway between 0 and -1. Because remember, positive 0.5 recurring positive would be halfway between 0 and 1, but if we attach a negative to it, it goes halfway between 0 and -1. So this is where near negative 0.5 repeating would go. How about 0.8 and 0.875? Anybody want to try it? No? About here? That would be 0.8 or 4/5. Where would 0.875 go? To this side or this side? To the right side a little bit, right?
Yeah.
So 0.875 would be that. Or 7/8. Okay, so in addition to ordering them, you should also be able to put them on a number line. And nope, we're not quite done. How would you deal with this question? Which fraction's greater?
Is this the lowest common denominator?
You could find common denominators, sure. Which would be
Well,
12. So -3/4 becomes
9.
-9/12. -2/3 becomes -8/12. And therefore, which one is bigger?
3/4.
Careful.
Oh,
The opposite happens, right? No, this one's bigger, right?
Yeah.
Okay, because it's closer to 0. Remember, the opposite happens. So -2/3 is greater. Or just do this. Change it to decimal and compare them. That's just as correct. So this is bigger in the positives, but it's smaller in the negatives. So that would be the answer again. Okay, last example. Write 3 rational numbers between each pair. And they sort of get progressively more closer to each other. This one, well, it's got to be smaller than 1.25, but greater than -3.26. Remember, a whole number is also a decimal number. So would 1 work? Is 1 between there? Sure. What else?
2.
2 is too big.
It's called, okay.
-2? Yes, because that's bigger than this one.
Would -3 work or no?
-3 would work. Because it's still bigger than that, but -4 wouldn't. -4 would be smaller than -3.26. 0, -1, any decimal number, like you could have done 1 point, or you could have done 0.5, 0.6, whatever. Okay, so there's lots to choose from in A. B, not as many to choose from. Well, what we may want to do here, yeah, okay, I'll let you answer.
Well, I'm you're right.
Oh, be confident.
Add an extra 0 to the answer.
Excellent. That's exactly what you do. Now you should be able to see more of a choice. So what would 3 numbers be between these? Remember, we're in the negative, so the opposite is happening. Can somebody give me one? -0.2. 255. Yes. As long as it's between 50 and 60. So negative 0.2, and then anything between 50 and 60. So we could do 51. Negative 0.2, we could do 57. We could do 58. We could do 59. We can't do negative 0.24 something because that's outside the range. Yeah, I know who it was. Kayla. Okay, this one. What would you want to do with these? You could go common denominators, but what might be an easier way? Yeah, go to decimal. Decimal is usually quicker for plotting and comparing. So negative a half is negative 0.5. 1/4 is 0.25. One's negative and one's positive, so there's tons of choices. What do you think? What might be an obvious number between a negative and a positive? Always. 0. Definitely 0. Well, it has to be smaller than this. Has to be bigger than this.
0.3. 0.3.
0.3? Or is that too big?
That's too big.
0, sorry, and
That's too big.
yes, so think of another one. That's smaller than 0.3.
1.
0.1. Good. How about negative 0.1? Would that work? Is that bigger than this? Remember, we're in the opposite world. This is bigger in positives, but it'd be smaller in negatives. So negative 0.1 would work. And then finally, this one, I'll go here. So I'm letting enough space. Well, let's go to decimal again. But this time, the two decimals would be negative 0.5 and negative 0.25. Maybe put an extra number on the negative 0.5 so they have the same number of decimal places. So basically, we're looking for numbers that are negative, 0 point, and in between 25 and 50. 26. Another one?
45.
45. One more.
39.
39. Well done. Good job. Okay. The next step is going to be, how do we add, subtract, multiply, and divide with these things? Okay. Which is not terribly challenging because you guys already know how to do operations with positive, negative numbers, and you also know how to do operations with fractions. And then decimals, we're just going to use calculator. Okay.